And welcome to you all to the next video, chapter number 2, video number 4. In this video we are going to see about thermal reservoir and about the sink and source. Next topic is the about heat engine, heat pump, refrigerator. Next third topic is the second law of thermodynamics. Second law of thermodynamics from Kelvin Planck statement, and second law of thermodynamics Clausius statement, and perpetual motion of the second kind. And fourth topic is equivalence of the Kelvin Planck and Clausius statements. Okay, the first topic in this video is the about thermal reservoir. Means Thermal reservoir means it is a large body. Whatever the energy, if you add to the system, to the whatever, it is a thermal reservoir means the word itself. It is a large body. It is a large body. Whatever the energy, if we add to this or extract from this, their property of the temperature, it does not change. We call such a bodies are the thermal reservoirs. Examples of natural reservoirs are the sun and sea water are the examples of the thermal reservoirs. There are the two types of thermal reservoirs. One is the source, second one is the sink. Okay, I told that whatever the amount of heat is extracted from this, their temperature does not change. Energy is extracted from the sun, their temperature does not change. Such type are called a source type reservoirs. Sun comes under the source type thermal reservoir. Sink is the whatever amount of energy is added to the body, their temperature does not change. Sea water also, their temperature does not change if how much amount of heat is added to this. Okay, such type of reservoir is called a sink. Called as a sink. These two are the natural reservoirs. Artificial reservoirs are the natural source is the sun. Artificial source is a furnace. Next, this is the sink. Sink is the natural. Sink is the example is the sea water or river water or atmosphere are the examples of the natural sink type. Artificial sink type condenser. Okay, the basic terminology we understood. What is the source and sink. The next topic, the second topic in this video is about what is heat engine. Heat engine, a primary object is that conversion of energy of heat into the work. That is a primary object of the heat engine. It is a cyclically operating a device. Heat engine is a cyclically operating a device which extracts energy from the source. Source is the height. Generally we take high temperature body as a source and the low temperature body as a sink. Heat engine extracts energy from source and it converts into the work, and it rest of the energy in the form of heat loss, it leaves to the sink. That is the heat engine. Okay, next about the heat engine. Heat engine, it is a device which receives or which converts the energy from heat energy to the work energy is a heat engine. For this, a part of energy is converted as a work and rest of the part is sent to a sink. This is a heat loss. The for the calculation of the efficiency of the heat engine is the W net to the heat supply. Heat supply here is the Q amount of H. QH. W net is the QH minus QL. QH minus QL. 1 minus QL by QH. This is the efficiency of the heat engine. Next is the refrigerator. Refrigerator is a cyclically operating a device which absorbs energy from the lower temperature of the body as a heat and it will extract to the refrigerator is a cyclically operating a device which absorbs energy from the lower temperature and it rejects to the high temperature body. That is the object of the refrigerator. When we supply double amount of work on the refrigerator. Once again, the object of the refrigerator is to maintain a low temperature of a room. This is the object. Suppose this is a room or a sink. Their object is that it will absorb the energy. It absorbs the energy as the heat from the lower temperature body to the high temperature of the body when external work is acting upon it. That is the function of the refrigerator. The object of the refrigerator is to maintain low temperature of the body. That is the object of the refrigerator. For this, we calculate the performance of the refrigerator by the coefficient of performance is the desired effect to the whatever the work is supplied. Desired effect is the QL. Whatever the heat is removed or extracted from the sink to the W. What is the work here? Work can be here QH is equal to the W plus QL. From this, W can be write as a QH minus Q suffix L. This is the COP for refrigerator. The coefficient performance of the refrigerator we can calculate from this formula QL by QH minus QL or TL minus THTL. Similarly, the next device is the heat pump. Heat pump also, it is a cyclically operating device which extracts energy from the low temperature body and it will reject energy as heat to the high temperature of body. That is the object of the heat pump. For the calculating the coefficient of performance of the heat pump is the same as formula desired effect to the work done. Desired effect is the rejecting the heat to the high temperature. Rejected heat is the QH to the work done is the QH minus QL. You can write in terms of temperature TH by TH minus TL This is the COP of heat pump. The second law of thermodynamics. There are these several statements of the second law of thermodynamics. There are several statements for second law of thermodynamics. Any statement that will denies that if there is any possibility of the spontaneous process is occurring on its own, okay, it won't accept, it will deny. We will see Kelvin Planck statement. Kelvin Planck statement. The statement is that it is impossible to construct a cyclically operating a device which produces no effect other than the extraction of energy as a heat from a single thermal reservoir and performs an equal amount of work. That is the Kelvin Planck statement. Kelvin Planck statement is that this is a source, this is a heat engine, heat engine, heat engine, W net with QL is the 0. Kelvin Planck statement is that the Kelvin Planck statement, what he tells from his statement is that it is impossible to construct a device. Suppose the device is heat engine. If the heat engine is extracting energy from the source, energy as a heat, extracting energy as a heat and completely converting into the equivalent amount of energy as a work without any losses, it is won't possible. That is his statement of the Kelvin Planck statement. That is completely complete conversion of the energy from heat to the work, it won't be possible. To construct such a device is impossible. That is losing without losing or with zero losses of energy, complete conversion of heat into the work, it won't be possible. That is, if it is possible, such a devices are called a perpetual motion machine of second kind. What he tells is that it is only possible that if the source is there, it is only possible the device is a heat engine. If we can, whatever the amount of heat is extracted from the source as a heat can be convert a part of energy into the work only, and rest of the part we can lose as a heat loss to the sink. That is the Kelvin Planck's statement. Okay, he his statement, it is impossible to construct such a device which is the equivalent amount of heat is can be converted into as a work, it won't be possible. That too with only heat is exchanging with only one thermal reservoir, and the energy interactions are also not possible from the his statement. See, if there is no heat loss, only one thermal reservoir. That is the meaning of the Kelvin Planck statement. Now here introduce the a word, perpetual motion machine of second kind. Perpetual motion machine of the second kind is a device which absorbs energy as a heat from a single thermal reservoirs and converts complete equivalent amount of energy as a work. That is the perpetual motion of the second kind. It won't be exist in practically. Next is the Clausius statement. Next is the Clausius statement. Before that, generally we all know about that the heat is always transferred from the high temperature body to the low temperature body by its own. Okay, it reverse won't be possible. Okay, that is the main concept of the second law of thermodynamics. Any spontaneous process or cannot be possible reversing by on its own. That is the second law of thermodynamics. From the Clausius statement is that he also has similar statement only. It is impossible to construct a device which, suppose this is a heat pump. The object of the heat pump is to convert the or transfer the energy as a heat from the low temperature low temperature low temperature body to the high temperature body with an external expenditure of the work is given. Okay, low temperature, high temperature. The object of the heat pump is to extract transfer of energy which is extracted energy from the low temperature body as a heat to reject the heat to the high temperature body with an external work input to the heat pump. Then only it is possible. What the Clausius statement is tell that without any external effect, only transfer of energy as a heat continuously from low temperature body to the high temperature body, such a device is impossible. With zero work, we cannot convert the energy from the low temperature body to the high temperature body. Is a impossible. Such a device existing is a impossible. That is a perpetual motion machine of a second kind. If it is exist, that is a perpetual motion of the second kind. That is the Clausius statement. Okay, the last topic in this video is the equivalence of the Kelvin Planck and Clausius statement of the second law of thermodynamics. It appears that Kelvin Planck and Clausius statement of the second law of thermodynamics are two different, but these are the equivalence. It can be going to prove that these two are equivalence by if the one violates the statement that leads to the second one and vice versa. Such a way we are going to prove that Kelvin Planck's and Clausius statement of the second law are both are equivalence. First we are the violation of the Kelvin Planck statement. The violation of Kelvin Planck statement. The violation of the Kelvin Planck statement is that with only a single thermal reservoir to the heat exchanges continuously, that to equivalent amount of heat is converting into the work. It is the violation of the Kelvin Planck statement. We are taking that statement that leads to violation of the Clausius statement. We are going to prove. First, writing the violation of Kelvin Planck. Kelvin Planck is the heat engine with only single thermal reservoir, conversion of heat equivalence amount of work is the W net without any heat loss. This is the violation of Kelvin Planck statement, right? there is no heat loss to the sink. This is a source. Now I am writing Clash's statement. Clash's statement is the heat pump can only work with an external amount of work. It can only possible convert energy from the low temperature body to the high temperature of body with only when there is a external support W net amount of heat is given to this device, then only possible to extract energy from the low temperature body to high temperature body. Can be possible transfer of energy as a heat. If you observe carefully, here is the with only single thermal reservoir, it is continuously conversion of energy from heat to the work it is occurring. That is the violation of the Kelvin Planck statement. This, if you observe this carefully, observe this, if you combine these two bodies, whatever the work W net is extracting from the heat engine is utilizing to run the heat pump. Okay, heat pump. Then whatever the energy is rejecting from heat pump is equal to the supply of heat engine is QH. if you assume this the function of this heat engine and heat pump as a single device, that is the heat pump. See, if we eliminate this, we can eliminate this source with single, whatever the energy is QH is like this. Now I am writing, this is a Q suffix 1, this is a Q2. From this statement, W net is equal to the Q1. This is the Q amount of H, which is equal to the Q1 plus Q2. We can write as this. We can write as this. This is a source. I am redrawing this figure as a sink. This is the heat engine. Okay, heat engine. It is giving Q1 amount of heat, which is help to run a heat pump. It is extracting Q2 amount of heat from this sink, and it is giving rejecting to the source, that is the Q1 plus Q2. Q1 plus Q2. If you eliminate this, whatever the Q1 is supplying, Q1 plus Q2 is supplying to the source, anyhow it is collecting Q1 amount from the source. So Q1 amount is, if you bypass this is the Q1 amount of heat. So it rest of the Q2 is rejecting to the source. Here Q1 amount of heat is coming from here, and Q2. If you see here with no loss, here Q2 amount of heat is transferring to the source of Q2 exactly the same, without any external input of the device, that is a heat pump. Here if you both combine and see, both works as a heat pump only without any expenditure or external heat supply. It is extracting same amount of q2 from low temperature body to the high temperature body is supplying. So it is a violation of the Clausius statement. Clausius statement. So the violation of the Kelvin statement, it leads to the violation of the Clausius statement. Okay. Now I am considering that the violation of the Clausius statement that leads to the violation of the Kelvin-Planck statement. First we considering this as a heat pump, that is the class according to the Clausius statement, the transfer of energy as a heat can be transferred from the low temperature body to the high temperature body is possible when there is a external work input is present. That is a Clausius statement. For this, if you remove this without any work input, if the energy is extracting from the low temperature body and rejecting to the high temperature body, that is the violation of the Clausius. Now I am considering with zero work input. So now I am considering first statement as a violation of the Clausius. This Clausius statement, that is the leads to the Clausius of the Kelvin-Planck. Heat engine, heat engine which extracts energy as a heat from the source as a QH, and a part of energy is converted as a work and rest of the part is left to the a sink, that is a q2. This is a q1. W is the q1 minus q2. if you see this if you see this q1 amount extracting from this sink and rejecting to the source, if you this q2 is supplying to this input to the heat engine heat engine then we the function of heat pump and heat engine together can be see as a one device, that is a function of heat engine. We can redrawing here. This is a source, this is a source. Whatever the q1 amount of energy is extracting from the low temperature that is from sink is the external heat supply. Whatever the amount of heat is extracting from the sink with the heat pump is the input supply for the heat engine, that is a q1, and it delivers work W and rejects heat to the sink is a q2. From this, with only one, this is a and it is extracting the heat from the source, and a part of energy is converted as this and part of energy is sent to the sink. That is a function of the heat engine. By seeing this with only one single thermal reservoir, the conversion of energy is happening continuously, which is the violation of the Kelvin-Planck statement. With the Kelvin-Planck statement itself is the only with one thermal reservoir complete conversion of heat to the work, it is impossible. Okay, because of this violation that leads to the violation of the Clausius statement, such a way the violation of the Kelvin statement, it leads to the violation of the Clausius statement and vice versa. From this we can say the equivalence of the Kelvin flanks and Clausius statements of the second law are the equivalence to each other. Thank you.